Hey guys, I just wanted to give you a video as to how to use the graphing calculator in case any of you were struggling with that part of the note, since I've been struggling to do it in class with everybody and just getting everybody to see it. So I'm going to go to example 2, the one we kind of left off at, where it asked you to graph the area function that we wrote, and then for what value of x is the area the largest. So yesterday we wrote the area as a function of x is equal to 25x minus x cubed. So if you want to find out where that value of x, where the area is the largest, first you're going to have to go to your graphing calculator, right? And you're going to want to type in the function that we wrote. I already typed them in. So if you go to y equals, I actually have all of the functions that we wrote in here. So we're actually doing this one, 25x minus x cubed. It's the only equal sign that I have highlighted right now. So it's the only function that it's going to graph. So I'm going to go to graph. Now, right now, my window is set to zoom standard, where it's -10 to 10 in all directions. So that's obviously not a great window. So if you're not sure what window you should be setting it to, you could try the zoom fit option. It's not always that great, but it gives you some place to start. Zoom fit is option number 0, and then it will change the window to a better window for you. Now, we're trying to find out what x value makes the area the largest. So we're looking for a local max, a peak. Now, we also said the domain of this was only from 0 to 5. So you're really only looking at this part of the graph anyway. And I can definitely see there's a peak right here. I'm just not like crazy about how it looks. If I wanted to get a little bit closer, now you could choose to change your window. Like if you wanted to, you could change your Y's. It doesn't look like it's going that high. Right now they're going up to 750 and it didn't look that high. So if you wanted to make it like -50 to 50 and just see what that makes the graph look like. Hold on. Sorry, I didn't put a +50. And if you want to change that, that might give you a better picture of the graph, and that's kind of better. So now I can definitely see there's a max right there. There is a definite peak. So to calculate it, we're going to go to second trace. We're going to calculate a maximum, so number 4. And then you have to get on the left bound side. So move your cursor to the left side of that peak, like right about there. And then move your cursor to the right side, hit enter, and then it's going to make an educated guess for what x value it gets the biggest area. And then you hit enter, and it says when x is 2.89, the area will be 48.11 square units. So that's the answer. It happens at an x value of 2.89. I think it asked to round to 2 decimal places. And then the y coordinate there, which is equal to the max area, is equal to 48.11 square units. Okay, so that's how you would have found the largest area that this rectangle could create. All right, let's go to example 3. Example 3 was in today's problem. It was the airplane problem, and it said in the last part, use a graphing utility to graph the function that we wrote and how close do the planes come to each other, at what time are the planes the closest. So remember, time was going in and the distance in between them was coming out. So we're looking for the x coordinate to tell us what time it happened at or how much time had gone by, and then the y coordinate would tell us that closest distance the planes ever came. So again, the first thing you want to do is take the function that we wrote in that problem, which is right here, and you want to pipe it into y1. Well, for me, it's not going to be y1 because I already have all of them programmed in there. So I'm going to go to y equals. I want to turn off this one now, and now I want to go to this equation. So I have the square root of 600 minus 400. You have to use x instead of t, the quantity squared, plus 400 minus 250x, quantity squared. Make sure you get out of that radical, hit enter, and now let me turn my equal sign on, and we can graph this one. All right, so now if I go to graph, again, I have the window setting from the last graph, so it may not be that great. I can see the wheel spinning. That's terrible. So if you want to go to zoom, option number 0, zoom fit, it will give you a better look at the graph. All right, now it looks like this one asked us at what time do the planes come the closest, so the distance would be the smallest, so we're looking for a local min. I clearly see a minimum right there at a point. I just want to get my window a little bit better. I want to get my y's. Let's get my y's a little bit lower. All right, and if I look at it like that, I may just see the better view of that dip. Yeah, so I can definitely see that there's a local minimum right there. So we're going to go to second trace, and we're going to go to minimum, right? So trying to find out the time that it takes the planes to get the closest. So the distance would be the smallest. So number 3 would be minimum. So you want your cursor to be on the left side of this local min, this little valley, if you will. Hit enter, then move your cursor to the right side, hit enter, and then you have to make it enter again. And it says that when x is 1.53, so when x time is 1.53 hours, because it was measured in miles per hour, so hours are unit of time, y will equal 21 point, I'm going to round that to 20. So the closest the planes will get is a distance of 21.20 miles, and it will happen 1.53 hours after they start traveling towards each other. So again, I'm going to say that x, which is equal to the time, is equal to 1.53 hours. It's going to take them to get to the closest intersection point. And then y, which is equal to the distance in between those two planes, is going to be 21.20 miles is the closest those planes will come to each other, okay? And that's how you would use your graphing calculator to solve that part of the problem. All right, and then the 2 problems we did in class today were the box problems. So the box problems looked like this one. I think we did this one first, right, with the no top, and we had the 24 inches, and it was the volume function, and then we did this one second. All right, so if we wanted to find in this part, it asked us to graph the volume that we wrote, the volume function, and for what value of x is the volume the largest, so we'd be looking for a local max. All right, and then what is the largest volume? That'll just be the y coordinate. So the first thing you're going to have to do is type this function in. So let's go to y equals. I've already typed it in, so let me turn this graph off now. Enter. Now you're going to want to type this function in, which is our x times 24 minus 2x quantity squared. So I want to turn that one on. And then again, you can ask it to graph it. The window is from the last graph, so it may not be that great. All right, it doesn't look terrible, but I still don't see the whole graph. And it asked us to find for what value of x is the volume the largest. So we are looking for a local max. Let me just get a better picture. Let me do zoom fit again and see if I can just get a better picture of the whole graph. All right, so it's giving us that. So I can definitely see that it's reaching a peak up there. That's kind of annoying. So I'm just going to change my window. So the Y max, look at it. It's going from negative 19,000 to 1,000. So I'm going to change my scale to count by 100. And then I'm going to let my Ys go up to 5,000 just to give me a better picture. And let's see what that does. All right, so again, I can still see that hump right there is going. So my local max is going to be right there. And if you want to keep changing the window, you can, but I know it's going to be right there. So we're going to do second trace. We're going to get our maximum. So we're going to get on the left side of this high point, and then we're going to get on the right side of this high point. Kind of big. So I'm going to make it wide, hit enter, and then it's going to ask you to make an educated guess, and you're going to say yes. And you're going to say when x is 4.000, the y value will be 1,024. So that means it'll take the value of x for which the volume is the largest. It'll happen when x is equal to 4.00. I actually think it's supposed to be an even 4. It's just the way the calculators are calibrated. I believe if you looked in the book, it would just say 4. But just to be safe, I'm going to put 4.00. And then that max area, or max volume, I should say, it's a volume problem, is going to be the y coordinate, and it said that was 1,024, I believe, when x is that value. So that would, and then it would just be units cubed. I don't know if it was in feet or what they gave us. All right, but it would happen, it would have a max volume when x is 4, and that max volume would be 1,024 units cubed. Okay, all right, and then the last problem was actually this one, where we had to do the surface area as a function of the length x, and it said use a graphing utility to graph the area for what value of x is a the smallest. So now we'd be looking for a local min, and they go what is the least amount of material needed. So we're looking for the x coordinate here and the y coordinate here of that local minimum. So the first thing you'd have to do is take that surface area function, again it didn't have a top, that we wrote right here, and type it into your graphing calculators. All right, so we're going to go to y equals. I have to turn this one off now, And then I believe I did it in. So there it is, y equals x squared plus, I put 40 divided by x in parentheses. I always get paranoid with division that they're going to break it up because these are scientific calculators. So I put it together in parentheses. All right, I'm going to ask it to graph it. So let me turn it on. I'm going to go to graph. Now, again, my window is all messed up from the other graph, so it may not be ideal. And I don't see it. So I'm just going to go to zoom fit again, zoom 0, and see what it says. All right, so we can definitely see, now again, we're dealing with like area and x values. X was the length of that rectangle, the base, I should say, that square. So we really would only be looking at x values from 0 on. I definitely wouldn't want the length of that square base to be a negative x value. So we're really just looking at this curve, and it asked us to find where the volume is I'm sorry, not volume, surface area is the smallest. So we're looking for that dip in the graph, that little valley right there. We're trying to find that local min. So I'm going to say second trace, I want a minimum. So I'm going to move my cursor to like the left side of that valley right there, hit enter, and then I'm going to move my cursor to the right side of that dip, hit enter, and then I'm going to ask it to make a nice educated guess. And it says when x is 2.71, that's when that smallest volume or surface area, will happen. And that smallest surface area, the smallest amount of material that will be used is 22.10 square units. All right, so it'll happen when x is 2.71. All right, that's going to be the x value, the length of that square base that creates the least amount of material. And then the least amount of material that will be used is the y coordinate, which is 22.1 square units. Okay, all right, and that's how the graphing calculator works. So again, if they're going to ask you to find the largest or smallest value, you're really just looking to find local maxes and local mins, those dips or those peaks on the graph. All right, if you have any questions about the graphing calculator, please reach out to me. I hope that was helpful if anybody was struggling with how to use them.